Okay, hi. So this is probably the video of your greatest interest, possibly. This is 3 point. So this is quiz 3. Okay, that's a little brighter. Okay, so yeah, so this is quiz 3 for MariyaS class. And so this might be a good prep for people who are studying for midterms. So hopefully I can get this uploaded tonight so that people have a chance to look at it on Sunday, a day before the final. So, anyways, this is my first question. So, the first question we had was going back to section 2.2 or 2.3, something like that. So, basically, decide whether matrix A is invertible. So, remember when it comes to whether there's an inverse or not, whether the matrix can have its inverse or not. That's one of the ways we can tell that right away is to use the determinant concept, right? So determinant of A equals to 0, then A inverse of A cannot exist. Remember we talked about that, right? So review the earlier sections if this doesn't seem to make much sense to you, but nonetheless. So by the way, try to solve the question on your own before you look at the answer, or if you run out of time, just go for it. But anyways, so because of that, so I just wanted to make sure it does exist. So if I'm gonna find the determinant of this matrix, and if it is not 0, then I can say it is invertible. So that's what I did. I find the determinant, and then I simplified the matrix using the elimination, typical elimination, 2 plus R. So these are the steps I went through. So now I'm gonna use this first column because it's got 2 zeros. So my strategy was there's 2 here and there's 2 here, right? So I could easily get rid of these 2, quickly eliminate all the leading coefficient rivals, and so that's what I have. 0, 0. So I can start right away. 0 times the first column and first row. That's gonna be -1, 0, 2, 3. I didn't bother writing because there wasn't enough space, but basically 0 times anything is 0. Second one is -1. And remember, I use a sign chart, but you can use the CNM that we did in 2.2, 2.1, 2.2, I think. Whichever works. I use sign chart, but there's other ways to make that happen, right? I think so according to the sign chart here, it's negative for -1, so it's going to be -1 times -1, and then I have 3, 5, 2, 3 because if I use the first column and the second first column and the second row, what's left in is 3, 5, 2, 3. So that's what I did. Next one, 0 times anything is 0. So, when I did the calculation, that's going to be 3 times 3, 9, minus 10. So that's going to be -1. So because it's negative, so determinant A is -1, and because of that, inverse of A exists because determinant is not 0; it's -1. Okay, and the question is similar for B. Let me scroll this down. Okay, there we go. So, so similar idea, but now the question is a little bit different because they give you the matrix A, and they do say it is invertible, but we need to find these unknown K so that, find all the K values so that this A is invertible. So, again, same basic concepts, right? I want to make sure the determinant of this matrix cannot equal to 0. So that's what I'm going to do. I'm going to try to simplify this as much as I can. This is tricky because they got K's, right? So you want to try to avoid using K to eliminate other things because you're going to have some expression rather than a simple number. So I'm gonna avoid touching R2 like a plague, and I'm gonna try to simplify as much as I can without touching the second row. So the first one I did, I tried to use this to get rid of some of the leading coefficients, which I've done right here. And then I was thinking, hey, wait a minute, 0, and all I have to do to get rid of is 2. Then I have 0, 1, and 0. Well, how do I do that? Well, I can't use the first row to get rid of this 2 because it's 0, right? So the only way now is use the second row, which I did not want to do, but now I have no choice, right? I'm too close. So because of that, I use second row to get rid of the third row's leading coefficient, but then at the cost I have negative 2k and negative 2k plus 1, which is okay though, because now I don't have, if I was using this expression to do more simplification, that might cause a problem, because the expression could go out of control. But that's okay, because by the time, just before that tipping point, I already found the second column where there's 2 zeros, so I can start right away. So 0 and 0, these I don't care. The middle one, 1 though, I can't ignore, and that one's positive according to the sign chart. So that's in 1 times. So first, second column, and a second column, and second row. So that's going to give me 1, negative 2k, and negative 2k plus 1, as shown here. 0 we don't care because 0 times anything is 0. So if that's the case, oh, there's some space here. So that's gonna give, actually, you know what? I'll give you an answer right away. So I'm just gonna write on top. So if that's the case, then that's gonna be 1 times negative 2k plus 1 minus negative 1 and negative 2k. So that's my determinant. So determinant A. So I'm just going continuing with this expression, right? Oh, and you guys can't see that, so I'm gonna raise it up. Okay, so that's that. So that's gonna be, let's see here, that's gonna be negative 2k plus 1. So that's gonna be negative 2k. So that's gonna be negative 4k plus 1. Yeah, so so that's my determinant expression, right? So how do I find k? So I just want to make sure negative 4k plus 1 is, which is my determinant, right? So that, let's say I make it a 0, right? I'll tell you why I made it 0. You don't want it to equal to 0, but I want to find the critical values. So that means 1 equals to 4k. I move the k hits this side, divide by 4, so that's going to be, I'm going to have k equals to 1 over 4. So, you know, that's what I have. Now, that's not my answer though, right? Because what the question says, find all possible k's where the determinant will be inversible. Yeah. This tells me that it's not inversible, because if k is 1 over 4, my determinant is going to be zeros, right? So on my answer, I should say, you know, so, A exists when k does not equal to 1 over 4 and k equals to all real numbers. That's that. And so yeah, and if you have time, just double check. But you know how to check, right? Just plug in the k, 1 over 4, 1 over here. You should get a determinant of 0, which means it's not possible. Any number apart from 1 over 4, we should be able to find a determinant that is not 0. So that was our first question. Both were, first one was out of 10 and out of 15 for us, but you know, what is out of it, you really shouldn't matter, right? It all depends on whether you can solve it or not. So that is that. Next question, next question will deal with the Cramer's rule. Okay, so this is question 2. So basically, thankfully we didn't get a very complicated equations. We just have, you know, two-dimensional question, thank God. But nonetheless, we have these two linear equations, and it says use Cramer's rule to solve. So, you know, this is what my matrix looks like. So I made A and A1 and A2 because that's the steps we use for Cramer's rule, right? We try to find the determinant of these, and then we use that determinants to find out our unknown variables, right? So A is this, the A1. So if you remember, right? So if A is just your regular matrix right there, and then A1 will be, so this first column is going to be replaced by your constant column, right? It's going to be 4, 3, 2, negative 1. A2 means on the column 2, it's going to be replaced by your constant column. So it's going to be 3, 1 as usual, but 2, negative 1 will be replaced by 4 over 3. You know, So that's what you need to remember. So we try to find the determinant for all these three matrices, mini matrices, if you will. Determinant A, so 3, -1. So we know how to find the determinants now by now, all right? So I found all the determinants for A, A1, and A2, and the only trick is because the first one you'll be looking for, see, it's the first column. The first column, right, A1, right? The first column is going to be X, right? And that's going to be Y, right? X, X, Y, Y, right? So when you find X, it's going to be determinant A, 1 divided by determinant A. So we already found those determinants, so plug it in, you have 2. Y is going to equal to determinant A2 because second column deals with the Y, right? Divided by determinant A. So determinant A is always going to be at the bottom. Depending on what determinant you put on top, you will get X, Y, or whatever, right? So in this case, I got -1. So, you know, this is your X value and this is your Y value for this to be true. So just put it in this nice form. X, Y is going to equal to 2, -1. That's all there is. Not that difficult. I think perhaps the easiest question. So, number 3, we're gonna talk about finding the Euclidean distance and playing the trick that we recently played, right? I think it was like 3.1, 3.2 or something. So, we'll look into those in just a bit. Okay, so so for the third question, basically it's about the Euclidean distance. So, this is what I did. So they gave you 2 vectors, so I just find the norm of net vector between u and v vectors. So that's what this is the question. Okay, so these are my answers. So I said this represents the answer you were looking for, Euclidean distance. So I found a net vector of u and v vectors. So that was 4, 0, 3. And then I just find the norm of that. So you got 5. So that's a pretty easy one. B is, so that's A. We will talk about B. So okay, so this is question 3B. So basically find the cosine of the angle between those vectors and state whether the angles are acute, obtuse, or 90 degrees. So I just listed these rules, right? These 3 things that I've asked you to memorize. So dot product of these 2 vectors equal to 0 means is orthogonal or 90 degrees. And the dot product of those is greater than 0, then it's acute. And if it's less, it's obtuse. So I put it into this format and then I just punch in the calculation, right? Vector of dot product u and v vectors. And then the norm at the bottom. You don't really have to do the norm. All we care about is this 2, right? But nonetheless, I did 42 over that. So I said because the dot product is 42, which is greater than 0. So it fits here. So it means the angle is acute between these 2 vectors. Now, that's all you need to write. But you know, it doesn't hurt to double check. So I actually wrote double check too. And the way you double check is, since you have that, right? So since cos equals to 42 divided by 2158, then angle is, right? You use a cos -1 function, right? So that is going to equal to 25.295, blah, blah, blah. So basically roughly around 25 degrees, right? So that is obviously acute because it's between 0 and 90 degrees. So that wraps up question 3. Moving on to question 4. And this is where I made a very tedious mistake, but I'll get to that later. Okay, so this is question 4. This is the projection vector one. So basically they are given with 2 vectors. And basically they're asking for vector component of u along A, that is W1. So whenever you see that key term, what should pop out of your head? Projections. So it's the equation that I've asked you to memorize, and this is incorrect, not yet, we will do that later. So we have this equation, so we just fill it in, that's not an equal sign, that's going to be just a vector A, so that's going to be dot dot dot. So everything should be straightforward by now, right? So hopefully that's the plan. Nothing too difficult, right? So the only thing is, they said that is W1 vector, right? So I think they want you to say W1 vector is this, right? You don't want to just give this because they want you to look for this. So nonetheless, it's the same idea. And the next part B is gonna be similar thing, but it's just gonna be orthogonal counterpart. Okay, so this is part B. So it's doing the same thing, but we're looking for orthogonal counterparts. So the expression is this. We don't have to calculate this again because we already defined project A and U, right? So because of that, we just copy down the U vector and then copy down the part A answer, right? Which was just this. So you do that, subtract them, just make sure you're paying attention to the fractional algebraic operations. But apart from that, I may have made a mistake. Oh, hold on a second, did I wrote this right? Oh, oops. Yeah, so good. Everything else checks out. It totally does. So I must have wrote this flipped for some reason. Okay, so yeah, so that's that. So this minus this will give you that. So that's gonna be your W2 vector. So that's all there is. We've done this question before. So on to the last two questions. Which is just finding the distance. Okay, so this is question 5. So basically the question is saying find distance between point -1, -1, 2 and plane of this equation. So this is a point to plane where plane is 3-dimensional. So we're using this equation, right? So just fill it in. You know how the drill goes, right? So A is going to so A, B, C, and D is going to be coefficients of each variables. 2, 5, -6, and if you move the 4 to the left side, it's going to be -4. So 2, 5, -6, -4, and then the X, Y, Z are going to be the points. -1, -1, 2. So -1, -1, 2, and below is A, B, C. So that's going to be 2, 5, and -6. 2, 5, -6. Do them together, you're going to get that answer. So distance between the point and the plane is that. So pretty straightforward. And the last question is the orthogonal one. Actually, the last question for 3.3. So it's actually, I think the question is exactly identical. So, but I'm still gonna go through it anyway. So here we go. So I won't really bother explaining this since I have explained my the section 3.3 part B. But yeah, so they ask you actually virtually the same question. And so my answer went like this, and it was all good. Oh yeah, and I don't have the room, and I don't want to make another video, so copy this question down. So I'm just gonna write one more detail that I wrote, which may or may not be necessary, but I don't want it to be thorough. So I also wrote, since U and V is required condition for orthogonal so you don't have to write this, this is a fancy way of saying in order for anything to be orthogonal, the dot product has to be 0. That's essentially what I wrote. But it might be worth writing that just to show them what does orthogonal mean, right? So these two will be more clear, right? So why did this person wrote this? Because this specific condition is what's required for vector U and vector W1 and 2 to be orthogonal. So that's all there is. So that was quiz 3. So hopefully you found this as easy as I have. And make sure you ace the test on Monday. And we will, I will be uploading the other videos too. Not right away, but hopefully sometime next week. I do have some catching up to do. The computer assignment, I'm going to try to get that done over the weekend so that I don't rush it next week. So we'll see how that goes. So anyways, but hopefully you found this comforting, or hopefully not discomforting. This wasn't a particularly hard quiz. So good luck, and stay in one piece. We'll see all of you on next week.